Assalamu alaikum. Bismillahirrahmanirrahim. Welcome to our JNCIS-SP service provider specialist course. It's routing, switching, and MPLS. We're discussing module 3, Junos MPLS fundamentals. So, this is the submodule of Junos MPLS. We are discussing Module 4, MPLS static LSP and the forwarding plan. So let's start. Uh, Today we share you some topology that is very helpful to complete your lab basically. Okay. So this is some terminology which is used in our MPLS backbone. This is the topology basically, and here use a logical system, and they are just define the logical system. This one router, the logical system is two, router 5 and 6. Router 1, router 2 is separate. Logical system, another logical system, um, router 3 and router 4 is present there, and router 7 and router 8 is present in another logical system. So if you want to implement MPLS, you can deploy MPLS in Juniper logical system. Logical system, nothing but it's a different routing instance, or you can say it's a VRF. Okay, it's a VRF equivalent to Cisco, but routing and forwarding. So if you just want to show you how to select the logical system and how to operate it. It's very simple. So, sorry. Sorry. So you can make logical system here, logical system, and you can set the name here. It's a defined name. You can set the name AMX1, or you can set the name like router one. Okay, so you can configure here. You can configure here. You consider this a logical system, or this is the logical routing instance. Okay, you can configure different routing protocol. You can add different interfaces. You can configure IP addresses under interfaces, and you can also configure MPLS and other protocol under logical system. Okay, just it's another physical route you can compare. Okay, everything is configured under this logical system. So if you want to practice this lab in physical devices, you can arrange two or three routers and configure logical system and deploy MPLS and making this topology. Okay, so in that case, this documentation basically show you they are taking limited router. That means I can just show you. This is, you can say it's a router one, this is router two, physical router two, and this is the router physical router three, and this is the physical router four, and this is the physical router five. Total router here 8, but we can practice by the using of logical system. 5 router is enough. Okay, or you can reduce more. You can reduce more. You can add 4 logical system in one physical router, another 4 logical system in another physical router. 2 router is enough to practice this topology. Okay, so this is the concept of logical system. Okay, then move forward. Similar, just so we already complete our topology. We already complete our topology. We don't make any logical system because we are just making this lab in virtual environment. So in that case, no need to deploy logical system under no need to deploy MPLS under the logical system. In that case, we are using individual router here. Okay. So if you want to practice in practical or if you want to practice in physical devices, so you can make logical systems. Okay. So in that case, two router is an app to practice MPLS in MPLS tools like static LSP or dynamic LSP, MPLS L2BP and L3BP. Everything is possible to check using the logical system. Okay, so it's a okay. It's the connectivity. Is how to connect your device, and this different logical systems show here. And why use logical system? The advantage is better for the planet, like physical lab, fewer routers required, less power used. Okay, so you can take multiple router. We need here the physical router is number of router will be 10. Now the number of MPLS backbone router is 10 and customer router is 2. So total router need 12. So if you use a logical system for MPLS backbone, you can arrange by using two routers and the customer S router will be different. Okay, so this is the very easiest way or easiest process to checking. Virtual lab, less CPU or RAM required, less power used. So we are using virtual lab, not the physical lab, so that I'm not making any logical system here. Less CLI windows to manage, use just one CLI window to manage all logical systems. So think one router have 4 or 5 logical system. So if you want to configure different logical system, just log in one physical devices and you will get all logical system under this physical router. So it's another advantage when you are making lab. Okay. So this is the advantage. So you can say uh, it's a physical, you can add physical interfaces in your logical router or logical systems. Like one logical system, see here, router 3 and router 4 is the logical router, and interface 2 is connected with router 3, 1 connected with router 3, and 4 connected with router 3. Just one thing, this interface will not connect with another logical system. Or say here 357. This is the different interface. Okay, interface will be different. So if you want to make sub interfaces like G0 by 0 by 2 have multiple sub interfaces, you can add one sub interface in one logical system and add another sub interface to another logical system. So in that case, you need a switch to interconnect with a logical system to another logical system, or you can use like example G0 by 0 by 4 and G0 by 0 by 5. You can add multiple sub interfaces here. You can make multiple logical system using these interfaces. Okay, so say here 4 5. This is the physical cable is connected, same router physical cable is connected with 4 to 5. And another advantage is here, you can also add here a logical tunnel interface. When you need to communicate one logical system to another logical system, you can add logical tunnel interfaces. Okay, it's worked like a physical interfaces. So moving between logical system, how to move one logical system to another logical system. You can set CLI logical system, then set the logical system name, and you can configure, you can verify your configuration as like physical route. as like physical router. Okay. So this is the I'm under logical system router 4 and I'm configuring the OSP as like physical router. No difference. Okay, no difference. When you show the total configuration, the configuration will be set logical system name, interface name, unit, family, init address. So if you configure this configuration in physical router, this option will be removed. This option will be removed. Okay. So this is the difference. Nothing big difference. It's very simple. Study tips maximize your lab time. It's basically lab betterment, nothing else. And um, we already complete our lab topology in last day and checking one C router to another C router, how they are communicate. Okay, so today our slide basically show the concept of logical system. Nothing else. Which command can be now we're in answer and process section. Which command can be used to exit from the logical system and return to the main route. That is clear CLI logical system. Or you can move one logical system to another logical system using the command edit. Like edit logical system R1. Now you are in logical system R1. When you move to another logical system, just press the top command. You will be in global configuration. But again, type edit logical system R2. You will move R2 logical system. That is very easy. What are the options to manage devices in your lab? Basically, it says the virtual student desktop console access from the front page of your lab portal. And which user can turn one router into multiple virtual devices. This is logical system. Static LSP and the forwarding plan. We already configured these and verify. Uh, we can make the static LSP from ingress to egress and reversely egress to ingress. Both way. We are making the LSP. Okay. So last step we already show edit protocol MPLS. And this is the configuration of the static LSP. And the verification command is run show MPLS LSP static MPLS static LSP. This router is ingress router, and this is the command verification. And you can show details. This is the label operation. Label operation is push, and this is the outgoing label. Because this is the ingress router, and if we checking from router 2, that will be the transit router. Similar configuration or verification you um, can add here. You can go router 2, root, and root 1 to 3. CLI, edit. This will be transit, not ingress. Transit. This is the verification. Two LSP is connected here. One for forwarding and second one for reverse. Forward and reverse. Okay. So I think that's all for today. Our topic was static LSP and the forwarding plan. We already discussed about this. And this is the verification command and the forwarding plan run show table, route, table, MPLS.c. MPLS.c is the forwarding table for static LSP. Forwarding table of static LSP. This forwarding table generating from this static LSP basically. Static LSP. Okay. So that's all for today. If you have any question or query, please. No question. Okay. So next class, the topic will be RSVP introduction. Okay. So I request you to join next class. That will be interesting. Okay. Thank you. Thank you, viewers.